In this demo, I have a new e-commerce application that I'm currently running in an on-premises OpenShift cluster. This app is built to scale, but I'm running out of hardware resources. It could be weeks before we're able to procure and install new hardware, so let's look at how I can use Kasten to quickly migrate this app to a managed Red Hat OpenShift service on AWS cluster and get the resources that I need today. We'll start by provisioning our target cluster directly through the Red Hat console. Obviously, this could all be automated via the CLI, but maybe not as fun to watch. Here, I'm providing our name and configuration settings for my cluster. And in just a few clicks, things are off and provisioning. While our cluster is provisioning, I'll come back to the K10 dashboard for my on-premises cluster and create a policy to perform a local snapshot of my SockShop application, which will then be exported to an immutable location in Amazon S3. We'll run our policy, and after just a few short minutes, my export is complete. Less than an hour later, my ROSA cluster is all ready to go. So let's get logged in and start by deploying Kasten on our new cluster directly through the Red Hat Operator Hub Marketplace. Installing using the operator will make it easy to configure our deployment and keep up with future updates. For this demo environment, we'll enable basic token authentication, but Kasten can also easily integrate with OpenShift's built-in OAuth server to enable secure multi-team self-service within the K10 UI. Once my Kasten install is complete, we'll log in, and the first thing we need to do is configure a location profile for the S3 bucket used to export my SockShop backup from our on-premises cluster. Next, I'll create a policy to import all available backups for our SockShop app, using the secure migration token from our source cluster. As the SockShop namespace doesn't yet exist on our target cluster, we'll filter for missing applications and then select the most recent restore point for our app. As part of our restore, we'll create our desired namespace, but critically, we also need to alter some of our application's manifest data in order for the application to work as expected on our new cluster. We call these transforms. The first transform I'm creating is to update the storage class name of all persistent volume claims within our app, as the vSphere CSI storage class is specific to my on-premises cluster. We'll change it to GP2 CSI, one of the available Amazon EBS storage classes on my ROSA cluster. Also, my app depends on an OpenShift route to expose its front-end service. The current host value is specific to my original cluster. I can use a remove operation to delete the existing value, allowing OpenShift to dynamically recreate it. Finally, We'll exclude the storage class from our on-premises cluster and start the restore. In our OpenShift console, I can see my data being restored and my SockShop app coming online. Once the restore is completed, I can see that the host value of my route has been successfully updated for my ROSA cluster. Logging in, I can see the persistent data associated with my app has been successfully migrated, and now my application is ready to take on any increases in demand. You can get started with Kubernetes backup, disaster recovery, and app mobility today with a free Kasten license by visiting the link on screen. Thanks for watching.